Whether you're a retro gamer or a modern gamer, one thing we all have to deal with is lag. This is the amount of time between a button press on a controller or a key press on a keyboard to when it's actually displayed on the screen. Now, this can be caused by a number of things, whether it's the wireless controller or keyboard, it could be the hardware itself or the software running on that hardware, and it could also be the actual display. Today, we're going to talk about the latter of those things, which is display lag. Some of you may already be familiar with devices that can test the amount of lag a display has. For example, the Time Sleuth is a very popular one by Chris 2600 and Citrus 3000. Unfortunately, from what I imagine is mostly due to the global parts shortage, this device can be tricky to get a hold of at times, and it's not the cheapest thing in the world either, let's be honest. But thankfully, the developers made the code open source, and another member of the community, Patrick's RetroTech, has ported this to run on a much cheaper bit of hardware. And that is this thing. This is a SiP Tang Nano 4K. These cost about $15 from AliExpress, and with a couple of extra components and a little bit of soldering, you can have yourself a very cheap but partially feature limited Time Sleuth. This will allow you to test lag on any modern flat panel display and even certain CRTs, although generally most CRTs don't have any lag. That's why people like them. But certain CRTs can have a terrible amount of lag. So let's take a look at how to build one of these devices and get it all up and running. The first thing we're obviously going to need is the Tang Nano 4K. I'll have a link in the video description to where you can find this. It's actually the affiliate link for Patrick's RetroTech, so all the money from that affiliate link will go back to him. The next thing I'd highly recommend is a PCB that actually mounts to this board, and that's created by ZW Energy. So we're going to grab the files from there and we're going to send them off to our favorite PCB manufacturer, PCBWay. All we need to do is grab the Gerber files from the GitHub page, head on over to PCBWay and click on PCB Instant Quote, add our Gerber files, and before you know it, you'll have nice high quality PCBs in your hand. We thank PCBWay for sponsoring today's video. So this little PCB is going to mount to the Tang Nano using some pin headers, which are normally included with the Tang Nano itself. So all we need to do is mount that on here. Of course, we do need to populate this with a few components. There are two resistors. You can either use through-hole or surface mount components. And obviously the LED, or it's actually a photo transistor. So that goes either in this hole here or on this pad here if you've got a surface mount one. And there's one single transistor which either goes here or just there for surface mount. Now the transistor that I'm going to use is a BC547, which is what Patrick from Patrick's RetroTech actually used in his build. If you look on the GitHub page for this PCB, he actually used a 2N7000, which is a MOSFET. I think either one will work just fine. I already had BC547s in stock, so I'm going to use that. Obviously, I also had the resistors on hand. They're a 1K and a 100K resistor, and I only needed to pick up this photo transistor. I actually bought this from J-Car in Australia. It was like $2 and it is a ZD1950, and this seems to work just fine as well. So that's the only part that I actually needed to order. Obviously you can also go for SMD components. I didn't have those on hand, so that's why I'm going with through-hole for this one. But you only populate one or the other. You don't have to put both in. So let's get our components soldered onto the board, and then we'll stick on some pin headers and mount it to the Tang Nano. So our 1K resistor is going to go in R2 here, and our 100K resistor is going to go in the spot for R4. Now, because we're using a BC547 and not the MOSFET that this board is designed for, we actually need to mount this backwards. So ignore the silk screen. We're actually going to put it so that the transistor faces the opposite way. Of course, if you're using the surface mount one, you can't exactly flip that over. So you want to make sure that you do actually use a 2N7002, which is the SMD version there. Finally, we've got the photo transistor. So on this one, the shorter leg is the collector and the longer leg is the emitter. So on this board, it needs to go with the collector closest to the outside edge of the board. So our short leg is the one on this edge. Let's give all this a quick cleanup. All right, cool. Last thing to do is just put on some pin headers. What I'm actually going to do, because the board mounts to this part over here, I'm just going to use just enough pin headers to cover the PCB itself. I won't go the whole length. There's no point really. So you'll notice there is a little tiny silk screen marking to indicate where this is supposed to mount on the board. So it is supposed to go up this way, like so. Let's just tack these in. I'll just clip off some of this excess leg. And that should be the soldering complete. Now we just need to program this thing. You can use the USB cable that should have been included with the Tang Nano. We're just going to hook this up to the computer. I'm using Windows 11, so that's what I'll be demonstrating this with. Okay, for programming, there's a couple of different things we're going to download. So first of all, from Patrick's Retro Tech, we're just going to get the latest release and download that zip file. This contains files for a bunch of different resolutions, so you do need to flash the Tang Nano every time you want to switch resolution. Thankfully, there is a better option for that, and that is a bit of work from ZW Energy. So if we look back at his repository and head to Video Lag Tester, we can download this Display Lag Tester multi-res release. You just want to grab the vlt.fs file. With those two files, we're just going to extract the original one that we got from Patrick's Retro Tech. So I'll just throw this in a folder. Yeah, that'll do. And here you can see all these load.cmd batch files. So if we double click on one of these, it may or may not work. Yeah, okay, so we get JTAG initialization failed. This is a driver issue, so there is one more thing that we need to download to get this all working properly. We're going to grab this program called ZADIG or ZADIG, I don't know. I'll have a link for all this stuff in the video description, so you'll be able to find it all, but I'm just going to grab the latest release here, and we're going to open that up. We're going to check our options and list all devices. Then we just need to find this JTAG debugger, interface 0. Now you do need to have this connected to the computer in order for that to show up. Click on that and we're going to hit replace driver. All right, driver was installed successfully. We can close that. Let's try and program this thing again. Aha, that looks better. So it's writing the new flash. And we're done. Now, as you can see, that's only going to output 480i60 from this thing. The other file that we downloaded is going to allow us to switch resolutions just with a push of the button on the Tang Nano itself. So let's flash that instead. So we're going to grab our vlt.fs and we're going to put that in the firmware folder, just like so. The only thing we have to do now is create a new batch file in order to flash that. So I'm going to show more options. Here we go, edit. So I'm just going to change this to point to vlt.fs. And we'll save that as a new batch file. I might just call it, just make sure that's all files, load multi. Cool. Now, if we run that batch file, that should flash the vlt.fs firmware, which will allow us to switch resolutions just with the push of the button on the Tang Nano. Looks like that all went well. We can finally disconnect this thing and test it out. One last thing you're going to want to do is cover up the sides of this photo transistor if you used one of the through-hole versions. So there are two options here. You can 3D print a lag tester case. This is actually designed for this and it's made by John 3D. So again, links will be in the video description. The other option is you can just stick a bit of black electrical tape just around the sides of the photo transistor, just so only the top is showing. If you let light in from the sides of this thing, you're not going to get accurate readings when you try and do the lag test. So for me, I already printed up the case. My 3D printer and my 3D printing skills isn't great, so it doesn't look too flash, but it does the job. Then we just need to put the HDMI in through this side. Actually, it goes up this way, so the transistor is facing the top of the case. Oh, and one last thing I should mention. This case is designed for the surface mount. So the hole in the case that's originally there lines up with the surface mount version of the photo transistor. I just had to drill another hole here so it lined up with the through hole version. Not a big deal, but you'll probably want to drill a hole if you're using the through hole one before you go inserting the rest of it into the case. And it is a nice snug fit in there. But that is all done. So we've got our HDMI output and we've got our USB for power and programming, but we shouldn't need to program this again. Throw the little cover on and we are ready to go. Now, if you don't have a 3D printer or you don't want to have the PCBs made up, you can make a ghetto version. I highly recommend not doing it this way, but it is possible to just use through-hole components soldered directly to the board. You just have to make sure you bend all the leads correctly so nothing shorts out. And you can see I've put a bit of black electrical tape around that photo transistor. This works, but it's fairly ugly and a little bit janky. So yes, this is what I'd consider the ghetto version. I highly recommend printing up the case and also getting that PCB made. So how about we swap sides and I'll show you what this thing can do. Okay, so here I have a mid-2000s Panasonic Plasma and over here obviously a Sony CRT. Let's check this out on the CRT first, that way we can just establish a baseline so you know what to expect from this thing, and then we'll see what the figures look like with the Plasma. So I've got the lag tester plugged into a USB power bank. We're just going to hold this up to the 3 flashing bars on the screen here, see what figures we get. This shouldn't come as a surprise to anyone who knows anything about CRTs, so we're seeing 0.5 milliseconds of lag in the top left, around 7.5 milliseconds in the middle, and around 14.5 milliseconds down the bottom. That's perfectly fine for a CRT. That's what we'd expect to see because a CRT doesn't have any lag, and the Time Sleuth is calculating those figures from the top left corner of the screen. So it takes about 7.5 milliseconds for the electron gun to scan from the top left to the middle, and about 14.5 from the top left to the bottom. A frame at 60 frames per second, which is what the Time Sleuth is outputting, is 16.6 milliseconds. So the maximum we should see on a CRT is 16.6. The exception to that, of course, is HD CRTs and widescreen CRTs, multi-format CRTs, anything that accepts 480p or 720p. They can introduce lag, but that's a subject for another video. Let's have a look at the figures from the Panasonic Plasma. Right, with the Plasma, I'm just using the HDMI out from the Time Sleuth directly into the Plasma TV. So let's have a look at these lag figures. We're currently set to 720p mode. So up the top, we're seeing 30.27 milliseconds. Ideally, we'd want to see around 0 if there was 0 lag. In the middle, we'd want to see around 7, and we're still seeing that 30.27. And at the bottom, we'd want to see around 14, but we're still seeing, again, 30.2 something. So the Plasma has around 30 milliseconds of lag in the top left corner, but down the bottom here, where it'd normally be around 14.5, we're still seeing that 32. So it's actually got less lag at the bottom of the screen and more lag at the top. It's almost 1 frame at the bottom, 2 frames up the top. That's a quirk with Plasmas because they draw the entire screen at the same time, whereas a CRT draws it line by line, and so do most LCDs and that kind of thing. But Plasmas tend to draw the whole frame at the same time, so there's actually less lag on a Plasma down the bottom of the screen. Now, of course, the other thing we want to test here is different video output modes to see if the lag is the same or if it improves or gets worse. So let's have a look at 1080i. The Plasma always reports 720p for some random reason. And we can see with 1080i, we're still getting around 30 milliseconds. It's probably going to be the same in the other modes, but let's check 480i. Yep. And 480p. And again, it's the same. So it doesn't matter what resolution we feed into this thing, it always seems to be around 30 milliseconds. Let's try some different settings on the TV, see if that makes any difference. So I'm currently set in cinema mode. In game mode, that did seem to change. I'm actually seeing 33 milliseconds, so more lag in game mode. Dynamic mode's about 29, so that's pretty good. And the normal mode looks to be about 31. So I normally have it in cinema because it provides the most sort of natural look. But yeah, it's interesting that in game mode, we actually get about an extra 5 seconds of lag. So I don't know what's going on with that. Maybe somebody at Panasonic is trolling gamers there. That's pretty random. Let's just try some of the other little settings, see if they make any difference. No. No, none of the other settings on this display seem to make a difference, but it's always worth testing those things because certain modes or certain display settings can introduce more lag. So it's always worth trying out different settings, and you'll know pretty easily if you have one of these what settings work the best. All right, one more display that I wanted to look at was this thing. This is a 4x3 LCD display that I did a video on about 6 months ago, and I found it had pretty minimal lag, but I was only using the 240p test suite to verify that. So I don't know what the exact lag figures are, so I'm keen to see what this thing actually does. Now, it doesn't have HDMI input, so again, I'm going to be using this HDMI to component video converter. I'll put a link to this in the video description down below, but as we saw with the CRT behind me, this doesn't introduce any lag. So let's try this out. I'm just going to hook it up to the Y component output, which is just Luma and Sync. And from there, you can either hook it up to a component video input, or you can just hook it straight up to a composite video input because we're not getting any color information from the Time Sleuth. It is literally just Luma and Sync. So you can use this with a TV that doesn't have HDMI or component video. You just hook it up to the composite video. Now, at the moment, it's not doing anything because it's currently in 480p mode. I think that was the last mode that we looked at. So we just need to click the button until it cycles through back to 480i because you can't go higher than 480i on composite video. Here we go. Okay, let's see what kind of lag this display really has. So up the top, just under 10 milliseconds. 18 there, and around 26, 27 there. So overall, that's about 10 milliseconds of lag if we consider that down here would normally be about 14, in the middle would be about 7, and up the top would be 0 on a CRT, where, yeah, 10 to 12 milliseconds, thereabouts. But that's actually not too bad for a flat panel display, especially a really old one. So this, I wouldn't be able to tell if there was any lag on there when playing a game. I mean, a top-level speedrunner might notice it, but certainly for most regular folk like us, we're not going to see or notice any lag on this display. The Panasonic Plasma, you might feel a little bit of lag. I thought like it had a little bit of lag, but you know, it's nothing that's really ever bothered me. I play games on that all the time and it seems to work just fine for me. So yeah, 1 to 2 frames of lag, I'm perfectly cool with, but certain people obviously don't like any lag whatsoever. So that is the Tang Nano 4K based Time Sleuth. It is a very budget device, but in most cases, it'll get the job done. Like I said at the start of the video, the original Time Sleuth does actually have some more features. It can output a lot more resolutions than this thing can, but you do need to program it with a USB blaster type device. So this kind of is a little bit easier to program, but it's not as feature packed. In saying all that, it's going to get the job done in most cases as long as the display can handle 60 Hertz. You shouldn't have an issue with this thing, but if you need 50 Hertz support or different resolutions, definitely look at the original Time Sleuth. So a big thanks to the people who made this thing possible. It is certainly a very budget-friendly way to test for lag, and no doubt you'll see it again on the channel. I still need to look at that HD CRT, see if I can get the lag figures down on that a little bit more, but in general, I'd probably say just avoid HD CRTs, I think is the recommendation, but who knows, maybe we can do something better with that. Anyway, a massive thanks to the people who support the channel on Patreon and allow me to make videos like this. And if you want to do the same, links to that are down in the video description. You'll get ad-free early access to all videos. But until next time, thank you all for watching, liking, subscribing. Be sure to share this around if you think somebody else might benefit from seeing this video. And I will catch you all in the next one. Bye. ghetto. Yeah.